Okay, so here we are at video 3, RAM. Okay, so what is RAM? Well, RAM, first off, is short for Random Access Memory. Simply put, RAM stores data that the computer may need to remember shortly. It's called random access because any part of the memory can be directly accessed. So because the computer may need this information soon, it's much faster than any other form of storage. Okay, so that might have been a bit vague, so let's look at a practical example. When you save an image to, say, your phone, it probably won't be needed immediately or for any essential processes, so the picture gets saved to your phone's long-term storage. If you were to load up a web page, it would need to put the web page on your RAM because you're likely going to be accessing that web page shortly. So since RAM isn't used for storing essential information, it is commonly rewritten over to accommodate new information, so that web page you loaded up might need to reload in just a little bit. So how is RAM used? RAM is quite useful for video gaming and graphical design processes. Video games will often need to load up new data rather quickly, so RAM is very helpful for making sure your game doesn't have to freeze and load up information. Graphic design programs such as Photoshop or After Effects use RAM to store temporary project files, so you can quickly go back to previous changes in the project. So, RAM versus storage. You might be wondering, why don't computers just get a whole bunch of RAM and get rid of the need for separate storage? Well, storage, as I'll cover in the next video, is much more permanent than RAM. Due to how RAM transfers and stores data, it becomes wiped when the computer is turned off or removed from power. Also, storage is much more accessible between systems, as you'll see soon. So, what does RAM look like? RAM look like long, skinny rectangles that have a row of bars with a notch in it lining the bottom. You'll often see a shell around the RAM in assembled computers. You can find RAM in sets of 2 or 4 on the motherboard, usually to the right of the CPU slot. So if we look on the left here, we'll see RAM, that's unenclosed, just how it looks normally. In the middle here, we'll see gaming RAM, and on the right here, you'll see a motherboard, and to the right of the square that's in the top middle, you'll see these 4 bars. Those are the slots that RAM goes into. So now it's time to talk about double data rate. Looking at RAM, you might notice that the notch may be in different spots between different pieces of RAM. This is an indicator of which DDR type the RAM is. DDR, or double data rate, is a term meaning that the RAM transfers data on both the rising and falling edges of the clock signal, which is basically a metronome the computer operates on. So DDR currently comes in 5 different variants, aptly named DDR 1, 2, 3, 4, and 5. As of writing this, DDR5 is very expensive and has little support from motherboards, but it's still something you can go out and buy. And DDR4 is currently very present in modern computers, both pre-built and assembled. And as far as I'm aware, you can't go into a store today and buy a computer or laptop using DDR3 RAM, but it's still very common in office computers today. So, this is a real good image. This is a notch comparison of the different types of DDR. So DDR1 is just a little bit off to the right, DDR2 is just a little bit off to the left, DDR3 is further right than DDR1, and DDR4 is in between DDR1 and 3. So, as DDR numbers go up, efficiency improves. Greater DDR numbers support greater clock speeds, which is something I'll cover shortly. It is also of note that DDR versions are not compatible with each other, so you should make sure your motherboard supports it before doing any upgrading. So you can't put a DDR into a DDR2 slot, nor can you put a DDR2 into a DDR slot. So, clock speed. Like CPUs, RAM also have clock speeds that serve as an indicator of how many cycles a second the device can process. Unlike CPUs, however, RAM clock speeds are measured in megahertz, MHz, and RAM clock speeds measure the speed of data transfer instead of processing. When you see something such as DDR3-1600, the clock speed of the RAM is going to be half that. In this case, it would be 800. The image on the next page shows the most common speeds for the different DDR types. So, here's that image. You can see DDR1 is 200 and 400 most commonly. DDR2 is 800. DDR3 is commonly 1600. DDR4 is 2400 and 3200. DDR5 is 4800 and 6400. So if you look at on the right here, IO bus clock, it's about half of what the number is. So for DDR3 1600, it's 800 megahertz. And these are not the maximums for these chips. I know that DDR4 can go at least up to 4000. So, RAM also has data storage, which is an indication of the maximum amount of data the RAM can store at a time. It's measured in gigabytes. Individual RAM usually have 4 to 8 gigabytes, so in pairs of 2 or 4, they have usually 8 to 16 gigabytes total. Okay, recap. So RAM is rectangular, short-term storage that have data rates, clock speeds, and storage capacities. So next up is long-term storage devices.